Hello, my fantastic folks. How are you? That's great. Hope you all are doing very good, right? This is Hershey, your science tutor, is back. The chapter number 9, which is electricity and circuit of your course book, Science Horizon, Grade 6, Acknowledge series by Amit Publishing House. So let's see what we are going to learn about electricity in this chapter. The chapter contains our electricity and its sources. Electric devices. We would learn about the electric circuit and its components now. Conductors and insulators. What all are these? And electric shocks and the safety measures that we are going to keep ourselves safe from the electric shocks. So are you all excited to know about electricity now? So without wasting time, just quickly start with the chapter. Have you seen this symbol? This is the symbol, red color symbol. Most of you have seen this symbol, but where? On the electric poles. Where? At the electric substation. Now, what is substation? Electricity is being generated in the power stations, then it is the power station is transmitting or sending this electricity to the substation, and from the substation it is being supplied to our homes and offices, right? So this is electric substation. Electricity can give shock. It can burn body parts and can prove to be fatal. It is very fatal for us. We need electricity to get light and do lots of work. So, whenever you see this symbol, the danger symbol, just be alert, right? There are many things in our daily lives that we do on electricity. We all are using electricity where? For the television, radio, fan, bulb, heater, washing machines. What else? It is refrigerator also, two wheels also, and so on. We have so many electronic appliances. These devices need electricity to work. So what do we call it? We call it electric appliances, because the appliances that run on electricity is known as electric appliances. Today it is difficult to imagine our lives without these appliances and electricity. If electricity is not there, तो कोई फायदा नहीं है इतने सारे appliances रखने का घर पर, right? So it runs on the electricity. So you can say electricity is a fuel for these appliances. Electricity has made our life comfortable and convenient. We depend on it for most of our work. So electricity is very important nowadays for our convenience. So let's start with the electricity and its sources. From where do we get this electricity? Electricity is a form of energy. Again, it is the form of energy, as we have seen in the case of light. It is the form of energy. Similarly, electricity is again the form of energy, usually supplied as electric current. We call it electric current through the cables and wires that I told you that it is being generated in the power station, and from the power station it is like coming to the substations with the help of cables and wires, and then the substations are what? They are sending this electricity to our places. It helps in many ways as lightning. We all know we light the tube light. We have tube lights, bulbs. So We are using this for lightning. We are able to see because light is present and electricity is helping in this, which is lightning, heating. We also get heat of it. We use some appliances like heater also. It gives heat also. Now running machines, etc. So there are many sources of electricity such as given below. So we will discuss about the source of electricity now. So we all know that electronics, what the electronic appliance is, right? And how the electricity comes to our home from the power stations, right? We will discuss about the electric cell, right? All you must have seen the electric cell in the remotes, in your watches, in the wall clocks, right? So a cell is most common device used to generate electricity. It is used where? It is used in radios, remote control, toys also. They need batteries too. They need cells, electric cells to move. And some toys are there that gives you light and the sound also. You'll hear the different type of sound. So how it happens? It is happening because of the electric cell. Tape recorders. Now we don't have tape recorders now, right? Nowadays we have the CD players, DVD players, so it all runs on it. So tape recorders, it was used in the earlier time. Earlier times means around 5 to 10 years back. Clock, torches, etc. A cell has how many terminals? It has two terminals. This is the positive terminal and this is the negative terminal. So positive terminal and negative terminal, the end of cell where you see a metal cap. So there is a metal cap when you hold a cell and you see the downwards, there is a metal cap. This is the negative terminal and this cap, I'm talking about this cap. So this you will find on the top of the cell. This is the positive terminal of the cell. The other end of cell is, so all the batteries have positive and negative terminals. Understand it very carefully because you will be getting more onto it in your higher classes, right? So this is the base of that chapter, the electricity, lights, right? So now we are talking about the cells, the electric cells. We have two kinds of cells. One is the primary and another is the secondary cell. Now what is primary cell? There is some chemical stored. How cell works? There must be some chemical inside it. When it is reacting, it is generating electricity, right? Am I right, students? Yes, there are some chemicals which is stored inside the body of the cell, right? So chemicals stored inside the cell that produces electricity. So when these chemicals are used up completely, right? These are used up completely, the electric cells stop producing the light. Such cells cannot be reused. Now you need to throw it to the garbage and it cannot be used again. Means reuse is not possible of the primary cell. So it is used in where? The clocks, the torches, we just use it when the cell is discharged or dry or it is not working, means the chemical which is filled inside the cell is used completely. So now we are purchasing a new cell from the market and again we are putting into the torches and the clocks and the toys, whatever we are using. Now this is called the primary cell which cannot be reused. Simple meaning is this cell cannot be reused. Now secondary cell, yes, there are some other cells that can be recharged once the chemical inside them are used up. When you recharge it, and it will again start working or start producing electricity. So this is the battery of phone. Nowadays the phones are coming, they don't have battery inside them. They have battery, but you cannot change it. These are fixed, so I cannot show you. But the mobiles that was there before 2-3 years, so they had this kind of battery. You can open the uh, flip of the mobile and you can take out and you can change the battery. So this is called the secondary battery, but the working is same whether you are changing or not, but you have to charge it. When the battery is not there, you'll see the pop-up message which is coming there, battery is getting drained in your phone. And what do? You immediately put the phone on charging and gets charged, and again it is ready for electricity. So they are recharged using electricity. Once recharged, they again start producing electricity. So such cells are reused, not replaced very frequently. So these are called secondary cells. So now you got the difference between the primary cells and the secondary cells. Primary cells cannot be reused, you need to replace it. Secondary cells can be reused after charging or recharging. So they are used in mobile phones, cameras, laptops, etc. Whenever you are using your laptops, your web camera, laptops, your tabs, your mobiles, you need to recharge it again and again after battery gets drained, right? So when someone rechargeable cells are combined together, it is sorry. What is battery now? Battery is when rechargeable cells are more than two or more than two cells when they are combined, and it is called battery. Individual, it is a cell, but when you combine them, it is called battery. Batteries are used in inverters, cars, trucks, etc. You'll find the batteries where? In the cars, in the inverters, trucks, right? So this is battery. So we have seen the sources, right? Sources, first is electric cell, then we have seen cells again, two types, primary and secondary, and another is third one is battery. Now moving to the mains, this is again the source of electricity. The electricity we get in our home is generated by power station that I told you in the beginning of chapter. From power station, it is carried to the home through cable or wires. We get the electricity at the mains electric board where the electric meters are put. So main is the main switch. You all must be having the electric meter where the meter is there, electric meter. So main is that point, right? So we are getting main, and with this meter you glow the light, tube light, and you switch on the lights and you can use the other electric appliances as well, right? It is fixed in our home from the mains electric board. The electricity is distributed to the different rooms in the house through wires. So how it is being carried from one place to another? With the help of cables and wires. It is being generated at power station, then it is coming with the help carried to the substations with the help of wire and cables. Then it is coming to the mains, which is the main board which is placed at our home, and one electronic electricity meter is also there. It counts the unit, and then according to the units you are paying the bill to the electricity department. Yes, we have to pay it for the electricity. Now electric devices. The electric device is an object that work on electricity. Some of the electric devices are electric bulb. Now, when the bulb glows, the main source of light is sun. But what do you do when the sun is not present in the evening or at night? How you will see? Because we have seen in the last chapter that the objects are not visible to us if light is not present there, right? So how we will see around us when the light is not there? Obviously, we use the electricity and we get the electricity or we get the light. First is electric bulb. An electric bulb is a device that gives light when electricity passes through it. It contains a transparent glass covering which encloses a thin coiled metal wire known as filament, and this filament is made with tungsten. Don't worry, I will explain you, I will show you the diagram also. Don't worry, just focus what I am saying. Electricity bulb you all must have at your home, right? It is there, it is present at your home. And have you seen the structure? It is made up with the glass, the transparent glass, right? I'll show you. This is the picture of a bulb. Nowadays the CFL are coming, but it again the basic is same. So this is the glass bulb, right? It was telling it is having a cover, it is covered with a glass bulb. So this is made up with the glass. It is transparent glass because transparent objects only allows the light to pass through it. So now you got to know that why it is made with glass only. So it is having the filament. This filament burns, right? It is not burning, it is glowing actually, and it is made up with tungsten. Yes, this is a metal. It is made with tungsten. So it is known as filament and which is made up with the tungsten metal. So you need to remember the name of the metal from which it made. The filament is connected to the two thicker wire. They provide support to the filament. It is for supporting of filament. What will happen if it is not having support? It will fall down. Then how it will glow? So the two thick wires, they provide support to the filament, right? I'll show you here. We have this two thick wires and it is giving support. So this filament is attached with these two thick wires, right? Just have rough idea. I'll explain you one more time, right? So these two thick wires give support to the filament, which is made by tungsten, and one of these wires is connected to the metal case of the base of the bulb, and the other thick wire is connected to the metal tip present at the center of the base. Now let's again move to the picture of this bulb. How we are discussing how it is working. So one thick wire which is connected with metal case. So this is the metal case. It is made with the metal. So one thick wire is internally it is connected. It is not visible from outside, but internally it is connected. So it is connected with metal case and the another one which comes to the metal tip or one terminal, right? So first is attached with the metal case. This is the metal case that I told you. It is the first terminal is attached to here and the next comes internally, it is coming to the next to the tip of this bulb, right? The other thick wire is connected to the metal tip present at the center of the base. The metal case and the tip of the bottom are two terminals. We have seen the two terminals, positive terminal and the negative terminal. These terminal is, you should know it. This is very important terms in if you are studying about the electricity, right? So two terminals of the bulb, these two terminals do not touch each other, right? Otherwise, if they are touching, the bulb will not able to glow. I'll show you in the I will explain you in this chapter only. Don't worry about this. Just have the idea how it works. The filament of the bulb glows when electricity flows through it. If the filament of the bulb breaks, it will not glow. Such a bulb is said to be fused. What happens? Sometimes when you are switching on, the bulb is not glowing. So what has happened? Maybe the filament that is made up with the tungsten wire, tungsten, which is this is a metal. So maybe the filament got broken. So because of this, the bulb is not working, and we call it the fuse bulb. The bulb is fused. Now understand with this image again. This is the outer covering. It is made with, I told you, it is made with glass. Fantastic. It is made with glass and it has the filament. It is the tungsten filament. It is coiled, right? It is fixed with two thick wires. These are two thick wires and it gives support to the filament. When you learn about the circuit only, how the electricity flows, it plays actually a very vital role to play in it. So internally we will see that first is attached with the metal case. This is the metal case. First wire is attached with the metal case and internally the another wire is attached with the metal tip. This is the metal tip. This part is metal tip. Internally it is attached with it. So these two terminal, one is the positive, another is the negative. So these two terminal must be separated, right? Metal case. This is the insulator. We will also learn what is insulator. So these two thick wires, they are connected with two different cases. First is the metal case and another point is connected with this tip, right? So when you switch on, it glows, electricity passes through this circuit and it glows. Now we will learn about the circuit also. Don't worry about this. Just focus here. Now the second is electric torch. It is again an electric device that gives us light. So hope you have cleared about the electric bulb. Are we clear, kids? Should we move to the electric torch? Very nice. So moving to this, electric torch is called a flashlight. The other name of electric torch is flashlight. A torch has cell inside and they are placed in such a way that the positive terminal of one cell is connected to the negative terminal of other cell. So positive and negative, just remember it. Focus on the positive and the negative terminal while studying this chapter. You will hear this term again and again here, right? So electric torch is also known as flashlight. And how torch works? It works when the cells are placed inside it. So cells are placed and because of the positive and negative terminals, it is glowing. So let's see the picture of torch. This is torch, right? So here are two batteries, first and second, two cells actually and when we are putting two cells or more than it, it is known as battery. So two cells are here. There is a spring. You all have seen springs in remote. So spring, and this bulb is here. Bulb is placed this side, and you have the switch on and switch off button here. I'll show you the working also, right? So internal structure of a torch, there are two components in a torch. One component has a bulb and the other has electric cell, right? We have just seen the electric cell and the other part which is having cells in here. So this is the first part where the bulb is placed, and this is the second part which has cells placed in it, right? It has two components. The cell provide the electric current, how the bulb will glow, when the electricity will pass, and how this will be passed. Either you like put the plug into the socket and then switch it on, but this is torch, this is mobile. Now again, what is the term mean mobile? The term is the mobile meaning of mobile means you can take it whenever or wherever you want, despite of the place, despite of the electric socket, electricity is present or not, you can glow it, right? So torch is the mobile device, and the cell provides electric current to the torch, right? Current is very important. Electricity is very important to glow it. This is the artificial source of light, right? So the cells are connected to a small bulb through a switch, right? You all must have seen the switch in the torch. When you switch on the torch, it will start glowing. When you switch off, it will stop glowing. Similarly as you do at your home, जब आप अपने लाइट का बटन ऑन करते हो तो लाइट और फैन और अदर अप्लायंसेस स्टार्ट होते हैं, एंड as soon as you switch off the socket, the button, it stops working. So there is a spring at the base of the torch. We have seen it, the spring at the base of the torch. The negative terminal of the cell remains in contact with the spring. So there is an order in which you need to place the batteries, right? So negative, you can see the negative mark also, and without seeing the marks on the cell, you can also identify the positive terminal and the negative terminal. How? Just hold the cell in your hand and you'll see the metal cap. So metal cap is the positive terminal always, and the bottom plate is the plate which is made by any metal. So it is the negative terminal. So you can see this is the positive terminal. Positive terminal is attached with bulb, and they are placed in such a way that negative terminal is attached with this spring, right? The metal tip at the base of the bulb remains in contact with the positive terminal of the cell. Now three metal strips in the torch. You will see a metal strip 1, metal strip 2 and metal strip 3. First is a part of switch. Move to this part again. Where is the metal strip 1? You will find it here. So this is the metal strip 2. I'm so sorry. Metal strip 1 you will find where? In the switch button. So this is metal 1. This is a wire. This is in the off condition as of now. It is not glowing. I will show you how you can identify this. So here, just understand, this is the metal strip 1. I will draw it one more time for you. So metal strip 1 is this, right? This is metal strip 1, which is in switch of the torch. And how do we do it? We slide the switch. This is the switch, right? We slide this switch. We push it forward and we pull it backward, right? So we are switching on the torch and switching off the torch. So first metal strip is there in the switch. Now second strip is connected to the metal case of the bulb. So where is strip 2? This is the strip 2 which is connected with the bulb. So this is metal strip 2 and here is the metal strip 1, right? So we have covered till here. This is metal strip and first part is connected with the bulb and the second part is in the switch, right? Now where is the third? Third metal strip is connected to the spring. Now move on to the spring. You can find it here, the metal strip 3. It is connected. You will find the spring in the remote control. So this is metal strip 3. In actual, this metal strip is one strip which is divided into 3 parts. This first part which is connected with the bulb, right? The second part which you will find in the switch. First part you will find in the switch. Second part which is connected with the bulb. And the third part which is connected with the spring. So metal strip 3 is connected to the spring. Only metal strip I can move. It can be pressed and made a slide. As I told you, we slide this button to switch it on or switch it off, right? So metal strip 2 and 3 are immovable. These two parts, metal strip 3, this part till here and second till here, is not movable, or you will call it immovable. These are not movable. Only metal strip 1 which is movable when we when we slide the on off button, right? So this is the movable part. The whole torch is covered in a plastic or metal case. So outer covering which is made with the plastic, right? So have you understood this torch? Just understand that how the structure from inside it is. How it glows, that we will study when we will learn about the circuit, right? So again I am explaining to you, this is the bulb. It is shown the bulb filament. This filament only glows, which is made with the tungsten only. So this part is reflector. Reflection we have just studied in the previous chapter. It throw or reflection means it is this surface, this shiny surface, as we have seen in the mirror case. It is the shiny and polished surface. So this reflector is also shiny and polished surface. It throw back all the light to the medium only, right? So this is reflector and this is the outer body, the bluish, which is the outer body of the torch, and 2 or 3, sometimes the 3 cells are placed inside it, or sometimes you find it as per the size. 2 cells are also placed it and 1 cell torch is also there. So if we are combining 2 or more cells together, it is called battery. So it is, you can see there is a metal strip which is moving from first part till the end, right? And it is divided into 3 parts. First part you will find it in the switch. Second, it is connected with this bulb. And the third you will find at the spring. It is connected with the spring. So C size is connected in the series. This is the metal spring. This is the metal strip. This is the internal structure of a torch. The working of a torch now. How it works. To switch on the torch, the metal strip 1 is pushed forward. When you switch it on, it is pushed off. It is a slide button. You all know what is push button and slide button. Push button, you just tick tock, tick tock, tick tock. It is a push button. Slide button, you just push it and it goes forward in the forward direction. And when you want to switch it off, just slide it backward. So this is the slide button or switch on the torch. The metal strip 1 is pushed forward. It touches metal strip 2 and 3. This complete the circle that is indicated by the glowing of bulb. Now again the term is used circuit, but I will explain you when the circuit will come in this chapter, right? So just understand that when we switch on, when we slide the switch on button, slide forward direction, the circuit is complete, right? The metal strip 1, it touches to the metal strip 2 and also touches to the metal strip 3. And when the circuit is complete, the electricity starts moving and the bulb will glow. Now switch off the torch. The metal strip 1 is pushed backward. As a result, what will happen? The contact between the metal strip is broken and the circuit becomes an open circuit, and that stops the flow of current and the bulb stops glowing. So again move back to the torch. We have seen the metal strip, as I told you, it is actually 1 and it is broken into 3 parts. So when we are pushing this slide button, this is the slide button, when we are pushing it in the forward direction, you can easily see in your textbooks, in this books, that the metal strip is broken here, right? There is a gap between these two, right? Like this is the ongoing circuit. So when there is a space between two. When you switch it off, it creates space, and when you switch it on, then this merges with the second part, first part, because first metal strip in the switch button, and when you slide forward, so it touches the metal strip 2 and metal strip 3 and circuit is complete. So let's see, when you slide it off in the forward direction, it touches here, right? And the circuit is complete. Now what happens, kids? Electricity moves from positive terminal to the negative terminal, right? So this is positive terminal. When you switch it on, the circuit is complete and the electricity is moving towards the bulb and this way, right? It touches the metal strip 2 as well as the metal strip 3 and so on. So this circuit is known as closed circuit. But when you slide backward, the option is when you want to switch off the torch, then what will happen? It will, when you slide it backward, so it breaks the connection and circuit is not completed. So what you say, this is the open circuit, and this open circuit doesn't allow electricity to flow, and the bulb will stop glowing. It will not start, it will stop glowing. Now electric circuit and its components as a closed path. Closed path we have discussed in the circuit when there is no space between the circuit. a bulb is placed, batteries is also there, the two cells were placed inside the torch. As soon as you slide in the forward direction, the circuit is complete and it is moving in the from positive terminal to negative terminal. But when you press it backward direction, then this circuit is broken or the path is broken and the bulb is stopped glowing. So closed path means the complete circuit is there. So closed path, you can understand with very simple when it is moving like, I'll show you in the straight path line. So like the bulb is here as it was, I'm not able to draw it, as it was there in the torch, electricity was getting, so there was the positive terminal. So again one more battery was placed. This is again positive terminal, this is the negative terminal, and this is the negative terminal. It is connected with this. So this is the closed circuit because there is no breakage of circuit. So electricity will flow from positive terminal to the negative terminal, right? And when the switch, when you slide the switch button to the backward direction, what will happen? Again, let's make the same kind of structure. This is positive, this is negative, one more cell is there, and this is the negative terminal, this is the positive. And when there is a breakage, let's say switch button was here, it is broken, and this is spring is also there, you make it right. So when there is a gap between the circuit, this is called the open circuit, means it is not completed, so this stops the electricity generation. So a closed path along with the electric current flows is called electric circuit. So circuit, this is the circuit. Closed circuit is allowing the electricity to pass in it. It has various electrical components, and electrical circuit has a cell or battery which is the source of electricity, right? A source of current. We will say current here now. So a cell or battery is a source of current. Now a key or switch which opens or blocks the path of the path of current. A switch is used to regulate. Regulate means switch on, switch off the flow of current in the circuit. It is called the key in a circuit. When the switch is off, it breaks in the circuit and the current stops flowing. If the circuit is not completed, it is open, so the current is not flowing into it and it stops. When the switch is on, the circuit is completed and current flows. Right? Hope you have understood this. I explained you while the explanation of torch. Right? This is the same terminology. Now, third component is a bulb. Bulb is also needed to glow. A bulb is connected to the circuit to indicate the flow of current, that current is there or not, or it is flowing properly. So how you would come to know about this? If the bulb is placed. When it glows, it means the current is flowing in the circuit, and when it is not glowing, so you can understand that there is some problem, either maybe the bulb is fused or the circuit is not closed properly or it is broken somewhere. Now connecting wires. Wire connects all the components of the circuit to enables the flow of current. These wires are made up with the plastic with any metal and plastic coating, right? We will see I'll tell you that why the plastic coating is necessary after this, right? So, but here the wires are also needed to connect this circuit for the connection. So, representation of a circuit. Now we will learn what is circuit and what is the open circuit, closed circuit. We know now, then circuit is open means it is not completely, and closed circuit means the current is flowing inside the circuit. So let's see, draw or represent an electric circuit on paper. And what all the symbols? This is the symbol of cell. So whenever you want to show a cell, you need to draw like this. This is a line, horizontal, then this is vertical line. Again we have a small vertical line and then this horizontal line. This represent the cell in electricity, and this part, if it is like this is the filament. Again, this how we show the bulb, right? And this is the battery. Again, horizontal, vertical, then space, then small vertical, then horizontal. This is the what? It represents the battery, right? As the battery is the combination of more cell, right? So that is why it is the battery. And single cell is there, so we represent it like this. So switch on, the symbol of switch on is this, means the connection is properly there, and switch off means connection is broken. So then you can see the space between these two wires, right? So this is switch off and this is the switch on condition. So you can understand it from this diagram. This is the circuit diagram. Here you can see the positive and the negative terminal. It is always there because it indicates the flow of current, right? So this is again battery. As I told you, this is the symbol of battery. So this is battery. It is this two dots, which means it is switched on. The current is passing. There is no breakage in it, and then it is moving towards the bulb. So this is bulb, and again the wire is coming and connected with the negative terminal, right? So this is the complete circuit. There is no breakage or no space. So this is the closed circuit, and electricity or current can pass through it, right? And your electronic appliances or bulbs or torches will glow or will work, right? If the circuit is closed, but if it is open, then this would be changed to this. This will show the switch of position, and otherwise what we need to हर बार हमें वो break करके फिर जोड़ना पड़ेगा. So it is very tedious job, right? So you have the switch off, switch on button. As you switch on, the circuit is complete or circuit is closed and current starts flowing. And as soon as switch it off, right, it breaks the this circuit. It breaks the circuit internally only. It is not visible to you. It breaks the circuit and current stops flowing in it, right? So this is the circuit. Hope you have understood the circuit and how current moves in it. Right, very nice. You all are very intelligent. I know this. And again, the current flow in circuit that I have already explained. Just go through it. When the switch in the circuit is on, means it is closed circuit. So current start to flow through the circuit. Current flows from positive terminal to the negative terminal, as I already explained you. It flows from the positive to negative. You can see this arrows that are formed, which shows that it is flowing in this direction. This is the positive terminal. So current is moving from this direction. right? And this is showing the switch on because circuit is completed. सारा सर्किट जुड़ा हुआ है, कोई ब्रेकेज नहीं है, means circuit is closed, and this closed circuit shows the switch on position, means current is flowing. That is why it has shown with the arrow. It is flowing from here, then it comes here, here it is moving, and it is moving towards negative terminal. So current always flows from positive terminal to the negative terminal. But when the circuit is completed and when this condition is there, when you press the switch on button or the button is switched on, then the circuit is completed and the current is flowing of the cell to the negative terminal of the cell through the connecting wires. Hope you all are clear. Understand it very well. This is very important thing. This is the base of electricity. Now, closed and open circuit, we already discussed. When the key is switched on, the current flows in it. This indicates by the glowing of the bulb. As I told you that how you will come to know the circuit is completed when the bulb is glowing. So, such circuit is called the closed circuit, and the circuit where connection are not intact. Intact means not attached, not properly attached, or you will say it is incomplete circuit or open circuit. When the key is switched off, the bulb does not glow, indicating that current is not flowing in it, the circuit. So this is called the open circuit, when wires are not injected properly or not connected properly. So you can see in this picture, this is the open and the closed. In the closed, the positive terminal is here and this is the negative terminal. So this wire is attached with the positive terminal, it is attached with the bulb, and then there is a key. This is called the key. This circuit is completed. This actually current is flowing like this, right? It is coming towards the negative terminal. There is no obstacle between this path, on this path. So it is freely, or it is flowing properly. Now open circuit, you can see this key is breaking. This is switch off condition, and this circuit, the current is moving from positive, from this way it is moving bulb towards this, and now where it will go? The path is broken, right? So this circuit is known as open circuit, right? Now conductors and insulators, I told you that why the wires are covered with the plastic or with the rubber. Let's see, we will cover here conductors and insulators. So when we can find the materials around us, some allow an electric current to flow through them while others do not. So the metals or the materials, the object that allows the current to pass through them is called the conductors, and the object that does not allow the current to pass through them are called insulators. So insulators and conductors both are needed. The materials that allow the electric current and heat to flow through them are called conductors, like metals like gold, silver, copper, aluminium. These are the conductors of electricity. Now conductors, even humans also, we are also the conductors of electricity. That is why we get shocks. Yes. And when we want to break this circuit, what we do? We wear slippers. It is made of the rubber, right? So rubber is the insulator. Rubber, wood are again insulated. It breaks the circuit, right? And we can prevent ourselves from getting shocked. So beside metals, moist air, salt solution, impure water, lead of pencil and graphite are also conductors of electricity. So graphite, you all know the lead of the pencil. So graphite is again very good conductor of electricity, impure water. So salt solution, you know what a solution when salt is mixed with water. So salt and water mixed and it forms the salt solution. So salt solution is again the conductor of electricity, and the moist air, right? So air, moist air, which is having the water vapor. Moist air means the water vapor that are present in the air. So moist air is again the good conductor of what? The conductors of, I'm not saying the good or bad, the conductors of electricity. Now, some materials do not allow an electric current to flow through them. They are called insulator, and examples of insulators are mica, ebonite, glass, wood, dry air, pure water, etc. are insulators. Water, the salt solution, water mixed with salt, is the conductor of electricity, whereas the pure water is insulator, right? Wood is insulator, dry air is insulator, but wet air is conductor of electricity. And wood, glass, ebonite, and what? Mica, they are the insulator. So conductors and insulator play different roles. For example, a wire are made of metals, but their covering is made with the plastic, while metals are the conductor and plastic is an insulator. Then only when you are touching the wires, you are not getting shocked. Yes, because of this only, right? If the insulator is not there, it is not covering the wires, the metal, the conductors, then if you are touching it, oh, we are again the conductors, the electricity conductors. Oh, you can understand what will happen with us. So while metals are conductors, plastic is an insulator. This is to safeguard us from electric shocks. Without insulator, you can imagine. So electrician wear rubber gloves, as rubber is again an insulator. It prevents them from getting an electric shock. So conductors are this: gold, silver, even copper, the salt solution, the moist air are the examples of conductors, where the insulators, plastic, rubbers, and mica, ebonite, glass, wood, right? Pure water, dry air. So these are insulators. Electric shock and safety measure. Electricity is very important for us to run our life smoothly, right? We cannot imagine our life without electronic appliances, without electricity, right? Because all electronic appliances runs on electricity. So electric shock can be dangerous for us. So we have to prevent ourselves from the electric shocks. So take safety measures. Many people die from electric shock, and electric shock is a condition wherein electricity of a high magnitude, means high voltage, passes through the human body. It is because the human body is good conductor of electricity, right? And electricity shock can have serious consequences ranging from nervous disorder to death. It is very dangerous. That is why the dangerous sign is made at power stations, substations, electric poles as well. We should not touch it. And in the class 1, class 2, class 3, we have studied that we should not switch on or we should not touch any electric appliance or socket with wet hands, right? This is very important to avoid electric shocks. Some of the ways to prevent electric shocks are replace the light bulb only when it is switched off and cool. The electricity also gives us heat, right? So when a bulb glows, it gets heated. So if it is fused, and you should change it when this electric socket or switch is off, because it stops the flow of current and it is cool. Never touch electrical switches or gadgets when your body is wet, right? And do not try to repair or install electrical wiring or appliances yourself. Don't be electrician now, right? Remember this. So do not touch electric poles, transformers, or a hanging wire on the road. These needs to be avoided. Never fly kites near overhead the power lines, right? So power is being generated where? The power station, and it is being transmitted to substation, and from substation it is being transferred to our places through mains. So never join the electric wires with bare hands, means without any precaution. Always use dry rubber slipper in foot. So here is a fact to know. Earth is also a conductor of electricity. We are human beings. We are conductor too. Earth is also the conductor of electricity. Hence, when current leaks from electrical appliance, it directly goes into earth, and this process is called earthing. Electrician knows it, but it can be asked in the question in the exams, and what is earthing? So earth is also a good conductor of electricity, and when any appliance leaks the current, there is a leakage of current in any electric appliance, it this current goes towards the earth, and this process is known as earthing. So now you know lot many things about the electricity, right? So whenever you switch it on, just recall all the concept that how the current is moving, and when you switch it on, so again recall, it stops the flow of current, right? And always take the safety measures which have been told to you. Now let's recall the flow of current constitutes electricity. A group of cells combined together form a battery. The main source of electricity in our home is the electricity mains. Electric devices such as the bulbs and the torch, which provides us light. The bulb has a filament. It glows when electricity flows through it, and the filament is made with tungsten metal. A closed path along with an electric current flows is called a circuit, or you will say it is closed circuit when there is no obstacle, right? Current flows from positive terminal to the negative terminal of the cell. It is always there. A circuit may be open or closed depending upon the arrangement of component and the flow of electricity in circuit. So components we have discussed. So when it is switched on, switched off, so the flow is depending upon some conditions. So let's move to the question answers. This first question is name two sources of electricity. So two sources of electricity are mains and the batteries or cells, right? So what is battery? A battery is when two or more cells are arranged or combined. So this is called battery. So name the part that glows inside the bulb. It is tungsten or filament. It is actually filament made up with tungsten metal. Give the other name of the electric torch. It is what? It is flashlight, right? So the question number 5, give a function of a key in a circuit. So key is responsible or it regulates the flow of current. When it is switched on, the circuit is closed and current is flowing inside the circuit, and when it is off, the key is off, it breaks the circuit. Now name the components of the electric circuit. A circuit is completed and what all are the components? It needs a bulb, it needs wire, it needs cell or battery, and it also needs key, right? Key or button. So what do you mean by the closed circuit? Closed circuit means the wires and the bulb, the wires, the cell and everything is intact properly and current is flowing without any problem or distraction. So define an electric device that runs with the help of electricity is known as electric device, like the bulb, the tube lights and the other electrical appliances, right? So that's all for the session, kids. We have enjoyed this electricity and the components and the circuit, how bulb glows and open and close circuit, the sources, so many things we have learned about electricity in this chapter, right? So I will connect you in the next session of science. Till then, stay excited for the clamp of another good years. Bye.